Hello. In this short video, we're going to look at how Grasshopper can lighten your workflow by automating processes that would otherwise require a lot of manual work. Do not worry if you're unfamiliar with Grasshopper. This educational video is aimed at beginners and uses basic mathematical functions and simple CAD instructions to achieve results. I am going to demonstrate the advantages of using such an approach with the following example. We are going to basically cheat a believable 3D model from the figure plan of this city. The script I developed can be used on any figure plan if you divide the outlines of the buildings in layers according to the number of floors each building has. This information is readily available on any platform providing you with satellite or aerial views such as Google Earth. The manual way one might go about doing this would be to tediously extrude each building outline to the desired height. Instead, we are going to do this for all buildings at once, introducing some variations to make the model seem more detailed and believable. This approach is not meant to provide you with accuracy, rather it is aimed at developing large areas with minimal effort. If you're using this to create a context model for your design, you can always add more precision and detail around the immediate area of your design later. Now, you will have noticed that part of this file has already been worked on. Let us finish this project with a walkthrough of the Grasshopper definition. This is the Grasshopper editor. You will notice that there are gray boxes called blocks and wires connecting them. This is basically how the program works. You start on the left and move to the right. You can insert a block by double-clicking anywhere on the background to reveal a search box and typing the name of the block you require into it. Then connect outputs and inputs by dragging a wire between them. Each block, which mostly corresponds to an action, describes to you, if you hover over it, what input it requires and what it can output. The yellow boxes are panels. Some are used as inputs and the rest as throughput or output. The through and output ones are not necessary for the definition to work, but display valuable information if you wish to understand how the task gets done. The definition works in the following way. On the left, we have the parameters governing the Grasshopper definition. This is where everything is input and controlled from. The upper row follows the geometry manipulation, where we will move from the input curves to surfaces and finally solids. Underneath this comes the math section, where we produce the height each building is later going to be extruded to. This number can be broken down to the ground floor, the floors above, and the addition or subtraction of a random value. Let's dive in. The first step is to reference the geometry on which you want to work in Grasshopper. In this case, the outlines for buildings with a specific floor count can be referenced as curves in a curve block. The second step is to use the referenced curves to create surfaces which form the base of each building. This can be done with the boundary surfaces block. If you're thinking that we could directly extrude curves, you would of course be right, but this would mess up any building with an inner courtyard, since Grasshopper cannot possibly differentiate between the building and the courtyard. Creating a surface first creates a region between the outline of the courtyard and the outline of the building, and this provides us with the required information to proceed. Next, we need to create a list of numbers which correspond to the height each building will be extruded to. This number is calculated as follows. The ground floor height, which is provided by an adjustable slider block, plus the sum of the height of the floors above the first. This would be equal to the total number of floors minus 1 multiplied with the multiplication block by the chosen height of these floors. Both these parameters can be defined by further sliders. As you can imagine, each mathematical function gets its own block, and I shall not keep repeating them. Finally, you add or subtract a little bit from each building to create the variance. This is the tricky part. To create the string of numbers, one for each building, we first need to measure the number of buildings. After having created a list of surfaces in the second step, Grasshopper can measure the number of items in this list using the block list length for us. We also need to decide how many steps of variation we are going to introduce and how high each step is going to be. These values can be programmed into sliders for easy adjustment. We are going to divide the number of steps by 2, find the negative of this result, and use both numbers, adding 0.499 to the positive one and subtracting 0.499 from the negative one, to create a domain with a construct domain block. This addition and subtraction of 0.499 is necessary for us to get normally distributed numbers after rounding. Finally, we need a seed number from the corresponding slider to generate a string of random values. Truly random numbers have not yet been generated by computer. Instead, Grasshopper uses a pseudonumber generator. Using the seed number, seemingly random strings of numbers can be reproduced. Changing the seed value will produce different results. Inputting the domain, the length of the list of numbers to be generated, and the seed into the random block creates a new list. When the values of this list are rounded to the nearest integer, we get a counter with a random number, which can be positive or negative, of steps added to each building. This number is then multiplied by the desired step height found in the corresponding slider. Adding the height of the first floor with the height of the subsequent floors and string of varied heights for each building, we finally get the total height for each building. The penultimate step is the extrusion of each building's base surface with the extrude block. The required input is of course the list of base surfaces previously created and a corresponding vector. The vector contains a numeric value as well as a direction. In our case, using the unit z block, we convert the list of generated heights into the required vectors, in essence explaining to Grasshopper that we want to extrude upwards from the original curve in the predefined height. The final block, brep, includes the extruded buildings. If you are unsatisfied with the resulting geometries, you can always play with the parameters. Changing the seed will generate a completely different set of random heights, which you might like more. When you are satisfied, you can right-click on the brep block to bake the geometry into any layer in Rhinoceros. This whole process can be repeated for other layers with a different number of floors. And this is the result, a complete 3D model in just a few clicks. By investing some time in planning instead of rushing to do the task manually, I have now created a tool that saves valuable time anytime I need to repeat this task in future projects. This is the beauty of this approach. By rationalizing and parametricizing an otherwise manual workflow, you can create tools that save time and allow you to focus on more important parts of your projects. You can use this program to develop tools that allow you to test environmental factors on a design, or using evolutionary solving to optimize a design, or just simple workflows that allow you to model faster, such as the one I have demonstrated here, just to name a few examples. My hope is that I might have inspired some of you watching this video into giving Grasshopper a try. Thank you for watching.